Okay. Right, so back on to this Emacs thing. Anybody ever used Emacs? Yep, right. I use it all the time. I don't use it. I use a derivative of Emacs actually, but back when I got my first PC in 1984, it came with something called Perfect Writer, which turned out to be a detuned version of Emacs with all the fixed key bindings. And I learned them then, and I've never looked back really. I still don't use VI, which of course sounds very irritating. Anyway, Emacs is stupidly powerful. Basically, it's a set of functions which you can then call from the language Lisp, which some of you may know. So you can play Tetris. The longer version of the talk's got a picture of the Tetris screen. Towers of Hanoi. You can check phases of the moon. Have a Java development environment, which is quite nice, and indeed other languages too. Manage files. There's one part of Emacs where you can actually say, give me a directory listing of one file per line, and if you just type Control-K to delete a line, that deletes the file. Or you can type over a name and it renames it, things like that. It uses script, as it says, written in a language called Lisp. You just attach a Lisp script to each key, and then that key will do whatever you say. So yeah. Emacs was also considered ridiculous because at that time it was considered a large program. And everyone said it stood for 8 megabytes and continually swapping. But in fact it wasn't. In today's terms it's all right. It still takes ages to build though. And then somebody said one day, oh, you mean you edit files with it? Yes, that was the original thing. And I'm just going to say a little bit about how Emacs came about, because it's good fun. You can get Emacs for pretty well anything. The ancestor of Emacs was a thing called TICO. And TICO stood for Tape Editor and Corrector, and it was for editing paper tape, punch paper tape, back in the day when that's where you stored your programs. And then it became the Text Editor and Corrector. When I went to do my Masters, we were told, well, there's an editor there which we've written locally called Ed, and it's very good, nothing like the UNIX one. Or you could use the manufacturer's one, which is called TICO. And I thought, well, I'm going to learn TICO, it might come in useful one day. And it did on several systems. And strangely, anybody ever done the assembler ROM on the BBC Micro? Yeah? Do you remember the editor on that? That's TICO. So, yeah, there I was having to edit some assembler on the BBC Micro for my job. And I already knew the editor, it's great. So it's worth doing. And I just thought, TICO commands look like line noise. Everyone says that. Whoops, I'm just keeling over it. It wasn't that. It was just, here's the TICO commands to create a file containing hello world and print it out. So you've got the star is the prompt. It's I hello world return 2 escapes. That inserts the string, including the new line, and the 2 escapes terminated. And then minus LT is go back 1 line and then type it out, and then 2 more escapes to terminate the command. And it says hello world, and EX to get out. You've got push down stacks, you've got registers to store stuff in, arbitrary text, all sorts of other things. Apparently you can use TICO to solve differential equations if you want to, but that's extremely stupid. But people have just pushed it to its limit. So TICO wasn't a visual editor at all, it's purely textual. But there was a version I produced which had some visual stuff. What Stallman did was write a load of macros in TICO that would allow you to do some more complicated things. And a hacked around version of that, because the source code was available, I stole it once. Then you could actually do some quite nice things. That's how Emacs came about. It was the extended macro system for TICO. You can get TICO now actually written in C. You can use it all the time if you want. There's a Wikipedia entry on it, TICO text editor. So go and have a look at it. Right, okay, so the next GNU product was indeed GCC, which many people know and possibly love. It's the GNU C compiler, and it was C++ as well. And then lots of other programs, and you can always tell a GNU program because it's got 4 million different options. They produce the UNIX. It's got the UNIX paradigm of one program doing one thing, but then doing it in so many different ways, it's ridiculous and totally confusing. And if you go to GNU.org, you can find out about that. All the software was released under something called the GNU Public License, the GPL. The GPL basically says, you can do what you like with this software. You can sell it, you can modify it, anything else. But if you modify it, then if you want to sell it, you have to give the user the source code. And you have to give it to anyone who wants it. And you've possibly seen when you bought some arbitrary thing like a router or something, there's some clause somewhere that says, if you want the source code that we added to this from the original GNU thing, then write to us and you can have the source code, because they have to do that. And there are variants because there's stuff about libraries which makes it more complicated. So GNU has got all these wonderful programs, overcomplicated perhaps, but they're there. So GNU became a software project looking for an operating system, but there was no operating system. They hadn't done that bit because that was the big bit. So back to the story, phase 3, we're now looking at the PC. The first PC UNIX that I can trace would be around 1984 when the 80286 came out. That's the PC-AT from IBM. And they produced something called PCIX, which stood for Interactive Executive. And it was an executive toy, basically. I don't think anybody used it seriously. The problem with the 286 was that it wasn't backwards compatible with the 8086 or the 8088, the IBM PC. You couldn't do anything else with it. Memory management was completely different. So it was actually worse than the PDP-1140. So, too bad. So various vendors provided Unix over the next few years, sometimes on the PC, sometimes not, but normally it was expensive hardware from somewhere else. One example of this, which I was talking to people about, was University of Kent Accommodation Office. Didn't ask anybody in the computing department, they just went out and bought themselves computer servers running their accommodation system, which was okay. You know, they could do that. We never got involved, and that was good, really. Then they decided to extend their offices, and they were in a house at the end of Giles Lane, and they suddenly wanted to extend to different offices, but they couldn't afford to have the wiring put through and everything else. So they slung cables over the roof, Ethernet cables. It was all right until the next thunderstorm. They lost the servers permanently. And I was used in my post at the time to getting reports of who was living in a particular student house so I could pull them in for a disciplinary hearing. And suddenly, instead of these nice printouts, I got bits from Excel. And they used Excel for 2 years and they ran the accommodation system on it, which is quite ridiculous. But Unix still hadn't properly cracked the commercial market. You know, you could buy these things, but people didn't because they were expensive, although the accommodation office and they did. And the eventual breakthrough was gradual, and it's all about free software, of course. And the catalyst was a system called Minix. Anybody come across Minix? Good, right, okay. Well, Minix was produced in the Netherlands. There's a guy called Andrew Tannenbaum. You've probably heard of him as a networking person. He's written textbooks on networking particularly. But he wrote a book on operating systems, which was called Operating Systems. And it was a real small Unix-like system with a different architecture, which was quite slow, but the whole point was that it demonstrated how you did things very clearly. The source code was in the book. You got the source code with it. You got the source code of everything, and it was free to students and educators. And that was exactly what was needed if you wanted to teach this stuff. The only thing you didn't get the source code of was the compiler, and that was because that belonged to the university. So you could do it on an IBM PC or compatible with simply two 5.25-inch floppy disks holding 360k each. That was enough. But you could also get it to run on the Atari ST and things like that, and the Apple Macintosh, the old Macintosh. Complete source code, you could modify and rebuild the whole system. I once rebuilt the system on a 2 floppy IBM PC, and it took me about a day, but it did work. You know, you could do it. And obviously the PC version was much popular because people had PCs. And all you needed was that. The next version of it had hard disks, and then they had networking and everything else. And it went all the way up to 2008, the last version. I think that's the 3rd or 4th edition of the book. And you still get all the source and everything else. So it was actually quite a good system for playing with. It wasn't intended to be anything serious, that was the thing. It was intended to be a teaching tool, and a learning tool. So the textbook was great, I've still got the various editions of it at home. But it didn't stop the people around the world from saying, well, yeah, it's very good, but it's a bit slow, so we could speed it up by doing this, and we could add this facility here, and we could do this, and we could do this. And there were countless arguments. I mean, I watched them go past on discussion groups of the day. And the various splinter groups developed saying, well, we've got the best Minix system because we've done this to it. Yeah, but you haven't got that, and it's a crop because it's that, and so on. So it's still around, is Minix. And you may well be running a copy of Minix without realising it, because the baseboard management controller of quite a lot of Intel systems actually contains Minix. In an unguarded moment, Andrew Tannenbaum said that Intel could use it, not realising what they were going to use it for. I think he was a bit pissed off when he found out. But there's an article there, there's a link which you can find on the slides. However, Minix may not have been the thing, but it was the catalyst. Linux. Linus Torvalds, who we've all heard of, and people either love or hate, I think. It's a derivative of Minix, basically. Minix gave him the idea, and it's apparently pronounced Linux, but then he's finished, so what do you expect? And very different architecture to UNIX or BSD, that's the point. Internally, written from scratch, it doesn't look much like Minix either, to be honest, but he wrote his own operating system kernel. Didn't write anything else. And there are differences internal and external, and since then, of course, Linux has had a lot of new things added to it, a lot of new system calls and everything else, which are incompatible in some way. But it was free, and it took 3 years for them to get to a stable point, but then it was there. And it was an operating system project looking for software. Obviously, you can see where this is going. He only produced the kernel, and he relied on the fact that GNU will provide the utilities. Not all distributions of Linux use all GNU stuff. It's entirely up to the people who produce the distro what they put in it. But generally speaking, and that's why a lot of people call it GNU/Linux. And that packaging was, of course, the different distributions you see, like Debian, Ubuntu, and so on. And this leads, of course, to the standard arguments about my distribution is better than your distribution, and why don't you use Arch Linux, and why do you... it's all a bit tiresome, really, but there we are. And the mascot is called Tux. That's even more irritating, I find. I don't know why, I just find the picture, that look is just horrible. There we are. So that's Tux, and that's the Linux mascot, and I'm sure you all know that. But let's go back to BSD. BSD was also being produced for the PC, for the 386 and above. They weren't stupid, they weren't going to go and look at the 286. The 386 has got proper memory management, it can do the job. And they produced something called 386 BSD, which is all very well, but the University of California at Berkeley were also producing their own version, which they were selling, called BSD 386. There were a couple of people involved with the University of Kent who were selling BSD 386, fairly unsuccessfully as it turned out. Basically the researchers fell out with the corporate establishment again. It's the same old story. And the two researchers were Bill Jollitz and Lynn Greer, or Lynn Greer-Jollitz when she married. And they wrote a series of articles about this, saying, look, porting UNIX to the 386. And I think there are about 6, 7, 8, something like that, articles in Dr. Dobbs' journal. Anybody come across Dr. Dobbs' journal? Yeah? Or its full name originally was Dr. Dobbs' Journal of Computer Calisthenics and Orthodontia. And it existed from, I think, about 1980-ish, I'm not sure exactly offhand, up to well into the 2000s when it finally folded. I have all the issues from about 1990 scanned now, including those articles. Now, it was pretty unstable, to be honest, because they didn't understand how the PC hardware worked. There was a massive blunder in the way they handled the interrupt controller, and it got corrected by many enthusiasts around the world. We've been here before, haven't we? Minix. I've got this fixed, and I've got this fixed, my bit works better, and so on. And there was one particular group which produced a system called FreeBSD. Free as in both senses, no money, and it's free to use. And once again, there were other groups. Two principal other groups, major things, are OpenBSD, which is still around, and that's really a standardization, correctness, cryptography, security, all that stuff. And the other one's NetBSD, which is all about high portability. So you can get it on all sorts of systems. I mean, you could run it on a PS2 and things like that. I mean, the gaming PS2. But FreeBSD is probably, as far as BSDs are concerned, has got the largest installed base. A lot of high-end server systems still use FreeBSD. And they're all based on the same source code, and the BSD people talk to each other. If something good comes up in OpenBSD, then the FreeBSD people and the NetBSD people start to use it. And they do a lot of cooperation. They may be operating their own thing, but they're very friendly. They work like the MIT people worked. And because they are pretty well the same, there are books that have been written about BSD for many years. And the latest one is now being renamed the FreeBSD internals, or whatever they call it. And that explains how it works internally, which is great. So you've got some reasonably good documentation. Linux has now got some of that as well, but for years the BSD ones were a lot better. And there are a lot of academic papers written about BSD because it's been around since the 70s. And it runs a lot of different hardware. The principal ones these days, of course, are the PC. You can run it on Intel chips, AMD chips, VIA chips, whatever. ARM, the Raspberry Pi, which is mostly the same thing, but entirely. And there are lots of others as well, which are now sort of second level ones. In fact, for FreeBSD, the second level includes the 386. Yes, the 386 is supported, but not as a top level system. Linux runs on quite a few too, but Linux. So, BSD had its own mascot called Beastie, and Beastie has had some interesting problems. That's Beastie. It's a daemon, and some of you will know a daemon is a process that runs doing things for the system. There have been some problems with the daemon. It's copyrighted by somebody, that's fine. But just to give you an example, I've got a couple of daemon t-shirts. Woman went into it was a BSD person, was wearing one of these t-shirts and went into some bar in the deep south and nearly got lynched. Why have you got Satan's picture on your t-shirt? And she explained, oh, and what is the government paying for this and all the rest of it? And they got so hostile that I think she ever got her drink. She paid, but whatever, I think she had to leave. And there are other people who have objected since. And so what they've done is they've actually, when you start BSD up now, FreeBSD, it doesn't show a picture of Beastie. It's just a little line drawing, sort of in characters. It now shows a sort of what's essentially a red ball with a couple of ears on it, which is a bit less demon-like. And the first thing I do is edit the boot file to change it to that one. Okay, so the user interfaces, this is sort of left over from where I gave the talk before, but you probably know that you still have the command prompt on Unix, and the command prompt is mostly what I use. I would spend some of my day reading mail and not using a command prompt mail program, but using a nice graphical one. And I will use Firefox. But then the rest of my work is probably done at the command prompt. This is very fast and productive, even if you can only type with your fingers. And everyone wants a graphical interface, and it's usually, apart from macOS, which is a UNIX system, provided by something called Xorg, which is equivalent to what used to be called, or still is called in a way, the X-Windows system. You're apparently not allowed to call it X-Windows, that's wrong. Because Xorg is the same everywhere, pretty well anything that runs on Linux should run on the BSDs in the same way. there should be no difference. The only proviso there is that you have a graphics driver that will work, because there normally needs to be a fairly complex graphics driver as part of Xorg. And if it hasn't been written for your system, then you can't use it. It depends whether you need a separate module or not. I've never had any problem. And what Xorg provides is a basic windowing system. If you've ever started up Xorg on its own, you just type X and don't give it anything else. It will present you with a single text window and nothing else. And then it's your job to produce more text windows or do anything else. So most people put a desktop environment on top of that. And the two common ones are called GNOME and KDE. I started off using KDE because it looked a bit like the previous system I was using. I very quickly found that I thought KDE was far too bloated and pushed you very much into using all their programs like their mail client and their file manager and everything else. I never really got into GNOME, but I did get into one called LXDE, Lightweight X Development Environment, and LXDE was fine except that they were going through some major changes and there wasn't any documentation. So I went on to XFCE, which is a very common one, and XFCE is what I use now. I can pick my own file manager, pick my own mail program and so on. Now, the important thing to remember is Xorg is completely separate. You don't have to use Xorg, you can use other things. There are other things available. It's just an application layer. And there's an old LXDE desktop, just to show you that it can look quite nice. It's pretty ancient, that one. I forgot what I was doing there, but it's got an old Facebook. It's got a calculator and a command window, and it has the obligatory cat, of course, or kitten, really. Right, so that's just about it. I've got some resources there. The unixhistory.tavi, that's tavi.co.uk, is where you will find the supporting stuff. Now, what I've done, it's not this talk, but you will find the longer talk there, not as a video because it wasn't taken, but what you can find is all the slides from the longer talk in two parts. You can find a verbal commentary, so you can flip through the slides and listen to me talk again about this stuff. And it's got a few other links as well. So that's where you go if you want to get the full history. And while you're there, you might want to look at bobeager.uk. What I've got there, if you look down the left-hand side, is various things. One is something called Mini UNIX. Mini UNIX was produced from a PDP-11 that doesn't have any memory management. And it's fairly little known. I just happened to manage to get hold of a copy of it. And the disks were on the wrong machine. I had to write part of an operating system to transfer them to our mainframe. But I kept them, and I've got them. And the Mini UNIX comes on similar sized disks to the old ones. I've got the full documentation for it, so I've put that online as well. And there are full instructions on how to install Mini UNIX on a low-end PDP-11 emulator. So you can, or even a low-end PDP-11 if you've got one. And it's pretty well like 6th edition. The only thing you will find that's missing really, mainly, is groups. The whole idea of user groups is not there because that makes it smaller. The other thing is 4.3 BSD. There's a fork of that, a later version of it called Quasi-Jarus, God knows why. And that is the sort of preferred latest hack that works reasonably well, 4.3 BSD. And all the stuff for that is available on there as well. There's a link for that, including full instructions on how to install it. You can either install it from a tape image if you want to be really, really complete, or you can install it from disk image, I think. It tells you how to get it running and how to get the networking going. So that's it. So those are on there, and you might find some other stuff on that website that's interesting too, including stuff about emulation and what have you that I've talked about before. So that's it. Any questions?